In this third series of lessons, we're going to spend some time trying to understand the basics of human movement. And really, to understand the basics of human movement, we have to consider the muscles that produce this movement. Really, they're the largest determinants of how we move throughout this world. So we'll spend some time in this presentation uncovering the different roles that muscles can play in human movement. Sometimes they're the prime mover. Sometimes they stabilize other joints around the joint that's moving. We'll also discuss the different ways that muscles can contract or produce contractions and influencing movement, such as a concentric contraction and an eccentric contraction. We'll describe a little bit of what these are and how they're different and how to figure out which is which. Really important concepts when we try to examine how a muscle is involved in a particular movement and how we then should train that muscle. And then finally, we're going to talk about the concept of open kinetic chain and closed kinetic chain movements. Open kinetic chain movements being where our extremity is free to move in space, such as when we throw a baseball, and closed kinetic chain movements where the end of an extremity, such as the foot, is on the ground, like when we're doing a squat. So all important concepts when we are describing movement, analyzing movement, and then using that analysis to produce really focused sport-specific or activity-specific exercise programming. As I said, what we'll really be covering here are three main points. The first being the different roles that muscles can play in movement. They can be a prime mover, they can be a stabilizer, or they can assist the prime mover as we go through the motion. We also have muscles that are going to resist the muscle or the motion that we want in an attempt to control the speed or enhance stability of the joints above and below. We'll also consider the different types of contractions that muscles can produce. Sometimes they produce tension and the muscle shortens. That's a concentric contraction. Sometimes they produce tension but lengthen. That's an eccentric contraction. And sometimes they produce tension and there's no movement, which is an isometric contraction. And then finally, we'll take a look at open and kinetic chain movements. We'll look at a variety of different examples so that you can identify how a particular extremity is moving, whether it be in an open or a closed kinetic chain. This is really important because the body functions in both of these methods, and we need to train appropriately in both the open kinetic chain and the closed kinetic chain to really enhance the function of the body as a whole. It's really important to understand the different roles muscles can play in movement. Now, a lot of these terms you've probably heard before and maybe even used, but I want to make sure we're all on the same page here. I found over, teaching this class over the years that there is a lot of misconception about these terms on this slide, as well as the concepts of a concentric and eccentric contraction. And these are really important to understanding human movement and how to train people in an effective manner. So let's first talk about a simple motion, right? Like bringing a cup to your mouth. So you want to take a drink from the cup that's held in this person's hand, right? So how do we do that? Obviously, it's going to involve motion primarily at the elbow and a little bit at the shoulder as well. So it's important to understand when we look at motions, first off, what joints are moving and how they're moving, right? So if we start in the position that's shown in this picture, and want to bring the cup to our mouth, we're going to have to cause elbow flexion, bending of the elbow, and shoulder flexion, which is a movement of the humerus in an anterior direction. The muscles that are the movers of a particular motion are called the agonists. The prime movers are the agonists of a motion. Often there are multiple agonists, multiple muscles who are going to be very involved in a particular motion. In this motion, I would probably say the primary mover is the biceps brachii. And the reason I say the biceps is the primary mover is because it does both of the motions we want to do to bring the cup to the mouth. It does elbow flexion. It also is one of the shoulder flexors. So the primary mover of this motion is the biceps brachii, and therefore it's called the agonist of this particular motion. Synergists is another role muscles can play. Synergist means helper, right? It means to help out or assist in some way. Synergists can really be two things. They can be muscles that provide additional force to a movement, so they help especially if I'm trying to produce a large amount of force, which I'm not doing in this exercise or this movement. But if I want to produce a lot of force, I can pull additional muscles in to help. Additional muscles or synergists that would help out here would include the brachioradialis, because it's an elbow flexor, the brachialis, because it's an elbow flexor, and probably the anterior deltoid, because it's a shoulder flexor. Synergists also could be muscles that produce or reduce unwanted movement. For example, if I contract the biceps very forcefully, the biceps also does supination of the forearm. And if I need to counteract that supination so I don't dump over this glass, I could pull like the pronator teres into action, and it would counteract the supination part of what the biceps does. So synergists can be either of those two types of roles. And then finally, antagonists are muscles that do the opposite motion. They do the motion that's opposite of the antagonist or of the agonist. So in this case, since the biceps is the primary muscle causing this motion, the triceps would be the antagonists of this motion. That does not mean that the triceps are active during the motion. These are just the muscles that would counteract this motion. So they are the muscles that oppose the agonist. They produce the opposite motions. And again, the triceps does elbow extension and shoulder extension. So it is truly the antagonist of the biceps. So understanding these different roles is really important to kind of analyzing motion, which we'll do throughout this class, figuring out what muscles are utilized primarily, so that we can target them for training so we can enhance the performance of a particular motion. Some additional considerations when looking at the roles muscles play warrants a little further, more in-depth look here. Remember, muscles, they aren't smart. They don't, they have an origin and insertion, a place where they attach to bones of the skeleton. The origin is typically the proximal attachment. The insertion is the distal attachment. But muscles, when they develop tension and they shorten, they don't pull on one or the other. They pull equally on both the origin and the insertion. So when I do elbow flexion, if I do a bicep curl in this case, the biceps not only is pulling on the forearm, it's also pulling on the scapula where it originates. Because the scapula is attached to the body and it's easier to move the forearm than a whole body, it's the forearm that moves. But also we utilize muscles to help prevent that motion, right? When you are doing a bicep curl, especially a maximal bicep curl, you have to fire your core muscles, muscles around the scapula, and so on to keep it stable so the only thing moving is the elbow. Well, that's another role that muscles can play. Muscles can take the role of a stabilizer, which is where they stabilize the origin of the agonist to prevent unwanted movement, to maintain posture as we do the exercise, right? So those muscles are still really important because they are stabilizing the body. They're giving us a nice base of support for the biceps to work from, but they're called stabilizers. But it's an isometric contraction, a contraction where the muscles develop tension but don't change length and movement doesn't occur. And then another role, as I mentioned earlier, which often is linked to the synergist role, is what's called a neutralizer. And when a muscle acts as a neutralizer, it does, as I said on the previous slide, it prevents unwanted action of the agonist. So in the case of a bicep curl, remember the biceps does both shoulder flexion, well, I shouldn't say both. It does shoulder flexion, elbow flexion, and forearm supination. So if I want to do a bicep curl and I don't want to supinate my forearm and I don't want to flex my shoulder, I have to contract additional muscles to prevent those motions from occurring. So then the biceps results in only causing elbow flexion. So those are a couple other muscle actions and roles. And the example specifically here for elbow flexion. Now that we've examined the roles that muscles can play, let's talk about the different types of contractions that they can produce. So muscles are, their purpose is to develop tension. When they're stimulated by a motor neuron, they are going to attempt to shorten. They're going to develop tension. Now, as I said before, they have an origin and an insertion, and when they develop tension, they're going to pull those two bony landmarks towards one another. They're attempting to shorten. However, when we contract a muscle. It doesn't always shorten. Sometimes when we develop tension within a muscle, it does shorten, and that would be a concentric contraction. Sometimes we develop tension in a muscle, but it does not change length, and there isn't any movement. That would be an isometric contraction. And then sometimes we develop tension in a muscle, but the muscle lengthens at that same time. That's an eccentric contraction. But let's look at each of those in a little more detail. A concentric contraction is when the muscle develops tension and shortens. So I'm holding a weight in my hand here with my elbow at 90 degrees, as I see in this picture. I can develop tension in my biceps if that tension in the biceps exceeds the resistance or the weight of my arm and the weight I'm holding. Then the muscle will shorten and the elbow will flex. That's an example of a concentric contraction because the muscle develops tension and it shortens, and that results in movement of a joint. That's what we usually think of when we're lifting weights, as a concentric contraction. But remember, the up phase of a motion typically is a concentric contraction of the agonists and any synergists. But what happens when we relax that muscle? If we turn those muscles off that just did elbow flexion, what happens to the weight? It would rapidly fall to the ground, correct? Well, that's not what usually happens when we're lifting weights. We don't lift things up and then just relax and allow them to drop down. We lower them in a controlled fashion. So if I lift that weight up and then want to slowly lower it back down, as we typically do in any kind of resistance training program, that still involves the biceps. That movement is elbow extension, right? Like when we lower the weight, our elbow is extending. And yes, the biceps does not produce elbow extension. What's producing elbow extension here is gravity and the weight of the weight and the weight of our forearm, right? But the biceps contracts eccentrically to allow the weight to slowly lower. So the biceps pulled it up, and then the biceps slowly relaxes. It produces an eccentric contraction. It's still developing tension, but it's developing tension that's lower than the force of the weight and the force of gravity on the arm. So it allows for a slow, controlled extension of the elbow. And that's an eccentric contraction. When a muscle develops tension but lengthens, that's an eccentric contraction. So a lot of people, when we do motion analysis in this class, and I ask you to analyze something, if they choose the biceps curl, they say the biceps is active on the up phase and the triceps is active on the down phase. And that is not true. The triceps is mostly quiet during the bicep curl, both up and down phase, because it's the biceps that lifts the weight up when we do the elbow flexion, and it's the biceps that still develops tension but controls the lowering of the weight. If we lifted the weight concentrically with the biceps and then used the triceps to lower the weight, what would happen is we would throw the weight to the ground because the triceps and gravity would accelerate the weight very rapidly towards the ground, and this would be an uncontrolled reaction. Think back to the original picture of the person drinking. If I lift the glass up to my mouth, concentrically utilizing the biceps to bring the glass to my mouth, if I then use the triceps to lower the glass to the table, I would throw the glass towards the ground and the water would spill everywhere. That's not what I do. I use the biceps still eccentrically to slowly lower the weight back to the ground. So make sure you understand, in many of our motions, a squat, for instance, we use the quads to push ourselves up. We use the quads to slowly lower ourselves back into the squat position eccentrically. So remember, a lot of these motions where we're working against gravity, we're using the same muscles on the up phase as we are on the down phase. We're just using them concentrically in one phase and eccentrically in the other. So the third type of contraction that a muscle can produce is an isometric contraction. An isometric contraction is where a muscle develops tension but does not change length. So in the case to the right, if I had a person, they were holding the weight, keeping their elbow at 90 degrees of flexion, holding that weight up against gravity, the biceps would be developing tension. So the biceps is developing tension, but that amount of tension that it's producing is the exact same amount of the force of the weight and the weight of the arm on the body. Therefore, we have kind of an equilibrium status where the muscle has developed tension, but it doesn't cause any movement. The muscle itself doesn't shorten in length, and the elbow does not move. So that's an isometric contraction. A lot of stabilization contractions, when you're standing upright against gravity, we're using a ton of muscles that are developing tension, but they aren't causing any movement or they aren't shortening. They're just holding our position. So isometric contractions are used very frequently throughout the body in stabilization type activities and so on. Obviously, we're always working against gravity, and therefore these muscles are acting in an isometric contraction way. So those are the three types of contractions that we can see muscles produce during motion. The reviewing again is a concentric contraction where the muscle develops tension and shortens, eccentric contraction where it develops tension and lengthens, and an isometric contraction where it develops tension and does not change length. In this class, we will be examining and analyzing and breaking down motions. And it's really important to be able to tell what muscles are active in those three particular ways during the activity, because often that's how we want to train these muscles so that they can work when we're doing real-life activities. In our next presentation, we're going to examine the terms open and closed kinetic chain, another important way to describe motion and understand how the human body works during the production of movement.